Let's use the unit circle definitions of the trig functions to actually calculate some values for the trig functions. So let's start out with this example. We'll find the point on a unit circle intersected by the angle pi over 3. So first let's draw a unit circle, so something like this. And angle pi over 3 is about like this. So we're looking for the coordinates of this point right up here. And this is supposed to be in a unit circle, so that means the radius here is 1. And we don't know the x coordinate or the y coordinate here. Okay, so if you recall, the definition of sine of theta in a unit circle, or in a circle, is y over r. And the definition of cosine of theta in a circle is x over r. So in this particular circle, the radius is 1. So for both of these, we can just put a 1 in the denominator. And also, we know what this angle is. It's pi over 3. That was given at the very beginning. So the first equation gives us sine of pi over 3 equals y. And the second equation gives us cosine of pi over 3 equals x. Well, sine of pi over 3, that's one that we know, or at least we should know. It's the square root of 3 over 2. And cosine of pi over 3, that's a half. And so now we know the coordinates of this point. This point is, let's see, the x coordinate is a half, and the y coordinate is the square root of 3 over 2. Okay, so since we knew the value of these trig functions, we were able to find the coordinates of this point. Let's have a look at another example. So let's find the point on a unit circle intersected by the angle 5 pi over 4. So let's draw a circle again, and we'll make it a unit circle. 5 pi over 4 turns out to be over here. And the radius of this circle is going to be 1. Well, just like in the last example, in a unit circle, sine is just y, and cosine is just x. So we need to know sine of 5 pi over 4, because that's going to be y, and we need to know cosine of 5 pi over 4. Because that's going to be x. Now I've made a mistake here. 5 pi over 4 is not up here. It turns out it's down here. Okay. The reason that I know it's down here is because 5 pi over 4 is 4 pi over 4 plus pi over 4. And 4 pi over 4 is just pi. So pi is a half turn, so 5 pi over 4 is pi over 4 more than a half turn. Okay, so now that I have this angle in the right place, let's figure out how can we evaluate sine of 5 pi over 4 and cosine of 5 pi over 4. Well, if you look at this angle, since it's pi plus pi over 4, the little bit of this angle that sticks out right down here is pi over 4. And if we go back to our right triangle way of thinking about things just for a moment, then this horizontal distance and this vertical green distance, those are things we already know. So the blue one is cosine of pi over 4, and this green one here is sine of pi over 4. And we know what both of those are. Those are both square root of 2 over 2. Well, if you look at this diagram, the x and the y coordinate for this point that we want in the lower left here, the coordinates of these points, this point, are the green and blue distances, except we only know the size of these distances. They're both square root of 2 over 2. But what that doesn't tell us is whether they're positive or negative. Now, because we are in the third quadrant, we know that both of these coordinates have to be negative. So sine of 5 pi over 4 is, we know that it's plus or minus square root of 2 over 2, but because of the quadrant we're in, we know it has to be negative. So that y value is negative. By the same token, cosine of 5 pi over 4, we know it's plus or minus square root of 2 over 2, but because of the quadrant we're in, it has to be negative. So that x-coordinate is minus square root of 2 over 2. So the general phenomenon here is no matter what, if you have any multiple of pi over 6, pi over 4, or pi over 3, I guess all the multiples of pi over 3 are also multiples of pi over 6, but if you have any multiple of these angles, you can find sine, cosine, and all the rest of the trig functions from the known values for pi over 6, pi over 4, and pi over 3. So we just saw an example of that. Let's look at one more example. Let's find, say, sine of 3 pi over 4 and cosine of 3 pi over 4. All right, well, on our circle, 3 pi over 4 is over here. Okay, and the idea is if you measure from the terminal side of the angle down to the x-axis in the closest direction, that gives you an angle that's going to help you find these two trig functions. So this angle, this is however much less 3 pi over 4 is than a half turn, and that's pi over 4. Okay, so sine of, what this tells us is that sine of 3 pi over 4 is going to be the same as sine pi over 4, but with either a plus or a minus. And we just have to figure out if it's a plus or a minus. But sine is talking about y-coordinates, and we're in the second quadrant where y-coordinates are positive. So we need a plus here. By the same token, cosine of 3 pi over 4 is going to be the same as cosine of pi over 4, but either with a plus or a minus in front. And to choose the appropriate sign, we just need to think about what quadrant we're in. Cosine is talking about x-coordinates, and in the second quadrant, x-coordinates are negative. So negative cosine pi over 4. Of course, sine pi over 4 is square root of 2 over 2, and cosine pi over 4 is also square root of 2 over 2. So sine of 3 pi over 4 is positive square root of 2 over 2, and cosine of 3 pi over 4 is negative square root of 2 over 2. You can see that as long as you keep an eye on what quadrant you're in, that's always going to let you choose the appropriate plus or minus sign. This idea of measuring the angle from the terminal side of your angle down to the positive x-axis, this angle here is called a reference angle. And so if you have any angle that isn't in the first quadrant, to figure out its sine, cosine, tangent, and so on, you'll always want to find the reference angle first. Okay, let's look at one final example. There it is. Let's find the values of all 6 trig functions for the angle theta in the diagram below. And I failed to draw my diagram. The diagram that I wanted is right here. So let's say this is -2, and this is 5. Okay. So for this angle, even though it isn't in the first quadrant, or because we're in a circle diagram, we don't have to worry about the fact that it's not in the first quadrant. So the nice thing about the circle definition of the trig functions is that it works for all quadrants, not just the first quadrant. So for sine of this angle, that's the y-coordinate over the radius. So that's -2 over 5. For cosine of this angle, that's the x-coordinate over the radius. Well, we're going to need to find the x-coordinate because we don't have it right now. So x squared plus y squared equals r squared because we have a right triangle here. So x squared plus y is -2 squared equals r, which is 5 squared. So x squared plus 4 equals 25. So x squared is 21. And so x is plus or minus the square root of 21. Now, as always, we need to worry about what quadrant we're in order to determine whether we want to choose the plus or the minus sign right here. But we're in the third quadrant, and in the third quadrant, x values are negative. So discard the positive, keep the negative. So x is negative square root of 21. So now we can come back and finish our cosine. X is negative square root of 21, and r is 5. Tangent of theta is y over x. Y is -2. X is negative square root of 21. And so this is 2 over root 21. And you can see, since we know all 3 sides of this right triangle, finding the other 3 trig functions would be a matter of just taking the appropriate ratios. So again, we see 2 main things from these examples. One is draw a diagram so that you know what quadrant you're in, and use that quadrant to choose the appropriate plus or minus signs for your coordinates. X and y could be positive or negative depending on the quadrant. R is always going to be positive because it's a radius, it's a distance. So R is always going to be positive. The second main takeaway from this is that if your angle isn't in the first quadrant, find the reference angle so that you can convert your trig functions to an angle that is in the first quadrant so that you can evaluate them. All you need to worry about when you convert to the first quadrant is whether you need to put a plus or a minus sign in front of the trig function.